morning, children. Welcome back to your chemistry class. So, we were left with this chapter electrolysis. So, I'm going to begin with this chapter electrolysis, and after that, we shall straight away move to the second term chapters also, because I cannot take the risk of leaving the chapters for the school to reopen and then to begin. So, after I finish with electrolysis, I will start off with the next chapter. I don't know which one, that I'll decide later, but when the exam begins, then maybe 15-20 days before, I'll stop and start off with some revision also of your first term chapters. So in the first term chapter, I think electrolysis was the only chapter which is left. So today I'm going to begin with electrolysis. Now, what does this word electrolysis mean, or how is it made? This word electrolysis, it is made up of two words. What are they? The first word is electro. This means what? Flow of electrons. Okay, and or flow of electrons or electricity. And the next word is lysis. What does lysis mean? Means separating. Okay, so all this, if we bring both the things together, what do we mean? That bringing about a chemical change in a substance by passing electric current. Bringing the chemical change in a substance by passing electric current. So how can we define what is electrolysis? Electrolysis is that chemical process which allows electricity to pass through and forms ions in it. Is this point very clear? Then there are many substances that allow electricity to pass through them, but maybe then there are many substances which allow electricity to pass through them, but there are also many substances which do not allow electricity to pass through them. Okay, so it has been found that all the substances, they allow passage of electricity. It is not necessary that they also undergo chemical change. Now I said a very important point over here. What did I say? That many substances, they allow electricity to pass through, many substances they do not allow electricity to pass through. There are many substances which do allow electricity to pass through, but then chemical change does not occur. There are certain substances which allow electricity to pass through and some chemical change takes place over here. So those substances which allow electricity and some chemical change takes place, the process happens by what? Electrolysis. I hope this point is very clear to you. Now, coming to most metallic elements, like your most metallic elements, I'm talking about, say, copper, aluminium, right? All the alloys, etc. Whether in their solid state or in their molten state, they always allow an electric current to pass through, but no chemical change takes place over here. So I'm talking about the metallic elements, though they allow electricity to pass through, but no chemical change takes place over here. Is this clear? The electricity can pass both in the aqueous as well as in the molten state. Then there are certain non-metals like say sulfur or even phosphorus, right? They do not conduct electricity. Follow? They allow electricity to pass through. They do not allow electricity to pass through. They do not bring about chemical change. Here when electricity is not passed, definitely no chemical change also takes place. So metals and alloys, what can we say? These metals and alloys, they are good conductors. They are good conductors and which do not allow electricity to pass through. What are they called as? They are called as good insulators. So good conductors and good insulators. Bad conductors are good insulators and good insulators are bad conductors. I hope you know this. You have already studied this before. Now, the conduction of current by a conductor is always due to what? flow of electrons, right? Whereas we know that insulators, they do not have mobile electrons, so they do not allow electricity to pass through. But these good conductors, they conduct electricity due to what? Due to free electrons. Okay, but over here there is no mobile electrons or ions present, therefore they do not allow electricity to pass through. I hope this is very clear. Now I'm going to talk about some chemical compounds that behave very differently in an electric when an electric current is passed through them. What some of the compounds, they conduct electric current in the aqueous state or in the molten state, but they do not allow the electricity to pass through in the solid state. In the conductors, what did we say? That they allow electricity to pass through in the solid, liquid, or in the aqueous state. Okay, but there are certain compounds which do not allow electricity in the solid state, but yes, they allow electricity to pass through in the aqueous or in the molten state. Certain compounds um, do not allow electricity to pass through in their solid state, but allow the current to pass through in their aqueous or molten state. Are you getting my point? Okay, these, they get decomposed by the passage of electric current, right? So these substances, they are called as good electrolytes. They undergo this condition by the process termed as electrolysis. I hope this is very clear to you. Now let us take an example. The passage of electric current through copper chloride solution. It decomposes it to metallic copper and chlorine. So such chemical compounds which conduct electricity or electric current in molten or in aqueous state, what are they called as? What are they called as? Electrolytes. Okay, which allow electricity to pass through in the molten or in the aqueous state, but not in the solid state. Whereas conductors, they allow the electricity to pass through even in the solid state. So one difference between conductor and the electrolytes is what? That conductors, they allow electricity to pass through due to free mobile electrons, and electrolytes, they allow the electricity to pass through only in the aqueous or molten state, not in the solid state. Okay, then we can also say these electrolytes, they are of two types. They are good electrolytes and there are non-electrolytes. Now as the word suggests, good electrolytes, they allow current to pass through, but non-electrolytes, they do not allow current to pass through. Do not allow current. Clear? So what do these good electrolytes they contain? They contain only ions. They contain only free mobile ions. They contain free mobile ions. Therefore, they are good electrolytes. Whereas non-electrolytes, they do not allow current. They contain only molecules. They have only molecules, and molecules do not allow electricity to pass through. I hope this is very clear. Now, there are also certain compounds which have mobile ions as well as molecules. Then what are those kind of substances called as? They are weak electrolytes. There are good electrolytes, there are weak electrolytes. Okay. So electrolytes can also be of, I can say, three types: good electrolytes, weak electrolytes, this is weak electrolytes, and non-electrolytes. Good electrolytes, they contain free mobile ions only. No, weak electrolytes, they contain ions and molecules. Okay, so it is termed as weak because molecules will not allow electricity to pass through. Only those few mobile ions are going to allow electricity to pass through. So definitely small amount of electricity is going to pass through, therefore it is a weak electrolyte. And the one which has only mobile ions, lot of current will pass through, that is a good electrolyte. The one which doesn't have any ions, it has only molecules, it will not at all allow electricity to pass through, so they are termed as non-electrolytes. I hope till here everything is very clear. Next, I want to also discuss some more points of difference between the conductors and the electrolytes. So first point that we know, that the in conductors, the flow of current consists of only single stream of electrons. Means electrons, they are flowing from negative pole to the positive pole. Whereas in the electrolytes, what do we see? The flow of current, it is two streamed. That is, one, it moves from positive cation towards the negative cathode, and the other one from the negative anion, it moves towards the positive anode. So in electrolytes, what do we observe? We observe two stream flow of current, whereas in good conductors we observe only single stream of electrons flowing. This is first point of difference. Some more point of difference between conductors and electrolytes. These conductors, the metallic conductivity, it is the property of the metals and the alloys, whereas in the electrolytic conductivity, it is the property of the electrovalent compounds. Okay, here the current flows due to the formation of electrovalent compounds, whereas there it flows only in the metals. Then next important point, what did I tell you? These conductors, they allow current to pass through even in the solid state. Okay, liquid also, but also in the solid state. Whereas electrolytes, they do not allow electricity to pass through in the solid state. They only allow the current to pass through in the aqueous or in the molten state. Then next point, the good conductors, they allow electricity to pass through due to free electrons, whereas conductors, they allow electricity to pass through due to free mobile ions, right? Last, the fifth difference between a conductor and an electrolyte could be, like over here, there is no change takes place. That is, if you bring a spoon and heat it, due to the free flowing of electrons, the tip that you hold, it becomes hot. Okay, but once when you take it away from the gas, what it will happen? It will cool down. So no chemical change has taken place over here, or in other words, we can say the conductors, they show physical change, hot and then cold, no new substances formed. Whereas in electrolytes, new products are formed at the electrodes, and therefore it involves chemical change. So I have verbally explained you the difference between the conductors and the electrolytes, which you need to write down in your registers. It is very important. Now I'm going to come across some important terms. Let's come to some important terms. The first one, as we have started, the first one could be electrolysis. So how can we define electrolysis? So I'm writing down all the terms, write it down. It is the process of decomposition of a chemical compound in aqueous solution or in molten state accompanied by a chemical change by using direct electric current. Okay, this is the formula for electrolysis. As we all know, it is a process of decomposition of a chemical compound in the aqueous state or in the molten state, which is followed by chemical change by using direct electric current. Okay, then we come to the second term, that is electrolytes. What are electrolytes? These are the compounds which either in aqueous state or in molten state allow electricity to pass through. Okay, so let's talk about as I had already told you, the electrolytes, they could be of acids, isn't it? Like H2SO4, HNO3, or maybe HCl. Then some more electrolytes in the form of bases. They are like NaOH, KOH, etc. Then the salts of uh, good acid and bases, right? Like for example, strong base, strong acid, they form NaCl. This is a good electrolyte. Similarly, CuSO4 and so on, right? Electrolytes, as I have told you, they are of two types. What are they? They are strong electrolytes, they are weak electrolytes. They are strong electrolytes and there are weak electrolytes. In this category, I would also like to place non-electrolytes. Okay, and let me once again explain you. Strong electrolytes, they only have ions present in them which allow electricity to pass through. Weak electrolytes, they have ions plus molecules present, so limited flow of current takes place because molecules will not allow electricity to pass through. And now non-electrolytes, they contain only molecules, and since molecules do not allow electricity to pass through, so they are termed as non-electrolytes. Okay, now let us differentiate between strong electrolyte and weak electrolyte. Now non-electrolytes, they are separate. Now we have come across strong electrolytes and weak electrolytes. So strong electrolytes, they allow large amount of electricity to flow through them, whereas weak electrolytes definitely will allow less amount of electricity to pass through them. Okay, then strong electrolytes, they are good conductors of electricity, whereas weak electrolytes, they are poor conductors of electricity. Then next, the strong electrolytes, they completely dissociate in the fused or molten or in the aqueous state, whereas whereas the weak electrolytes, they are partially dissociated in the fused or in the aqueous solution state. Then strong electrolytes, they contain only free mobile ions, Whereas weak electrolytes, they have both mobile ions and the molecules, so limited current will pass through them. Then the strong electrolytes, they always allow the bulb to glow brightly, whereas the weak electrolyte, it does not allow the bulb to glow brightly. Okay, some example of strong electrolytes could be your like HCl or NaOH or H2SO4 and so on. And in weak electrolytes, let us talk about weak electrolytes could be ammonium hydroxide, isn't it? Then I'm giving you examples over here. Ammonium hydroxide, then it can be calcium hydroxide, etc. So these are the these are the strong electrolytes, these are the weak electrolytes. Okay, now coming to some non-electrolytes. Non-electrolytes could be like non-electrolytes could be like distilled water. Okay, then you can also understand for alcohol, then even kerosene, then carbon disulfide, then cane sugar, etc. Okay, so these are all non electrolytes. I hope this much is clear to all of you. Next term that we are coming across is, third one is electrochemical cell. Okay, it is a device which is used to convert the chemical energy into electrical energy. So it is a device to convert chemical energy to electrical energy. Chemical energy into electrical energy. Clear? Then we come to electrodes. What are electrodes? These are the rods, right? Two plates of wires that are immersed in the electrolyte through which the current enters and leaves the electrolytic cell. Then these electrodes are of two types. What are they? Anode and cathode. Anode is the positive end of the battery and cathode is the negative end of the battery. Okay, then the anode electrode is connected to the positive terminal of the battery, that is termed as anode, and the electrode which is connected to the negative terminal of the battery, that is called as cathode. So when the current is turned on, the cathode becomes the negative electrode by which the electrons they enter the electrolyte, and the anode becomes the positive electrode by which the electrons they leave the electrolyte. Is that very clear? So now what is the difference between anode and cathode? So anode, it is a positive terminal of the battery and cathode is the negative terminal of the battery. Then at anode, anions they migrate. Then I can write over here, anions migrate, okay, to anode, and cathode, cations they migrate to cathode, migrate to anode, and they cations migrate to cathode. Okay, then anode, these are oxidizing electrodes, or oxidation takes place over here. Over here oxidation takes place, and over here what? Reduction takes place. Okay, At cathode it is always reduction, at anode it is always oxidation, right? Next we come to the new word ions. Now what are ions? These are atoms or groups of atoms which carry positive or a negative charges over them. These are called as ions. Okay, so atoms or group of atoms which carry positive or negative charge are called as anions. Okay, so what are anions? Atoms or group of atoms which carry positive or negative charge, they are called as ions. These ions could again be of two types. They could be cation, they could be anion. Okay, now atoms which carry positive charge, they are called as cations. Carry positive charge and negative charge. Clear? So anions, they are negatively charged, cations, they are positively charged. Thus the charge on an ion, positive or negative, it is always equal to the valency of the atom in the ion. Clear? Now let us also understand the difference between cations and anions. Okay, so these were the differences between the cations and the anions. We stop over here, and next video I shall come back to you with the oxidation and the reduction of these chemical compounds. Thank you.